This video is for section 8.3, number 27. A uniform plank of length 2 meters and mass 26 kilograms is supported by 3 ropes, as indicated by the blue vectors in the figure below. The tension in each rope when a 710 Newton person is 0.5 meters from the left end. This is an equilibrium problem, so we will use our two conditions of equilibrium, and those are that the sum of the net forces is equal to 0 and the sum of the net torque is also equal to 0. So what we should do next is draw the forces acting on our diagram. So tensions 1, 2, and 3 are already labeled, and those will be what we will be finding. The man also has a weight acting straight downward. Weight of the man. And then the plank also has a weight. It tells us it has a mass of 26 kilograms, so that means because it has a mass, it has a weight. And it's uniform, and the plank is 2 meters long, so the plank's weight acts at its center of mass, which would be 1 meter. So we can draw this right here. Weight of the plank. And let's indicate that is 1 meter from the left. We also need to pick a pivot point because we will be summing the torques. And a good pivot point to pick in this problem is the very left end where the tensions 2 and 3 are acting. And that is because tensions 2 and 3 act right at that point, and they would have a lever arm of 0 meters, and then we do not really have to include them in our torque equation because they would be 0. So our goal is to find tensions 1, 2, and 3, and let's first find tension 1 by summing the torques. Recalling that the torque equation is torque is equal to the perpendicular force times the lever arm D. The net torque is equal to, so the first force we see moving from left to right from the pivot is the weight of the man, and that is already perpendicular. And we have the lever arm, just D, the problem tells us is 0.5, so we can say times the lever arm of the man. And remember, when we're summing the torques, we need to determine if it's positive or negative. This torque is negative because it would cause the object to move clockwise. So we have a negative here, and that will be the same with the torque due to the plank. So we have the weight of the plank times the lever arm of the plank, plus the torque from tension 1, which will be positive, and we need the perpendicular component of that force, which would be T1 sine of 40 degrees, and then the lever arm of T1. And because we are in equilibrium, the sum of these torques is equal to 0 meter newtons. And looking at this equation, we know every value except for tension 1, which is what we're solving for, so we can rearrange and then plug in our values, and we will have our answer. The weight of the man is 710 newtons, and his lever arm is 0.5 meters. The weight of the plank It does not give us the weight, the problem gives us the mass, but we can just quickly use the equation weight is equal to mass times the acceleration due to gravity. So we have the mass, 26 kilograms, times 9.8 meters per second squared, times the lever arm of 1 meter. Divided by the lever arm of tension 1 is 2 meters, so the sine of 40 times 2 meters. And when you put these numbers in your calculator, you will get 474 newtons for T1. I'm going to erase this so we have room to solve for the second and third tension. So what we're going to do next is sum the vertical and horizontal forces. So we know that the sum of the forces has to be equal to 0 newtons because we are in equilibrium, and that also means that the sum of the forces in the x direction is equal to 0 newtons, and the sum of the forces in the y direction is equal to 0 newtons. Let's do the horizontal direction first. So T3 acts in the horizontal direction, and so if we sum our forces, we have the x component of T1 going to the right, so T1 times the cosine of 40 degrees minus T3, because T3 is going to the left, is equal to 0 newtons. We know T1, so all we have to do is solve for T3. So T3 is equal to 474 newtons times the cosine of 40 degrees, and that is equal to 363 newtons. So now we do a similar process in the vertical direction to solve for T2. So let's sum our forces in the vertical direction. Going up, we have T2 plus the y component of T1 sine of 40 degrees. And then going down, we have the weight of the man and the weight of the plank, and that is all equal to 0 newtons. So we know everything in this equation except for T2, which we're looking for. So let's rearrange to solve for the second tension. And this comes out that the tension in the second rope is equal to 660 newtons.